So today, all eyes and ears up here. Today we're diving into 9-6 and right triangle and trig ratios. A lot of this is going to be a review. There will be some new stuff. But to begin with, I want you to go through that Think and Discuss on page 437. Make sure you note how those angles and sides are labeled in relation to each other. Okay? Here we go. Okay, so note that, remember, sine A, if we were to trace angle A, the sine of A, in this case, is we've got the opposite side over the hypotenuse. So if you remember, we call it, in this case, so. How many remember what the phrase is we use?
Sohcahtoa.
Sohcahtoa, okay. So that's so. Some people write it like that. Some people write it as S-O-H, like that, to show it. Some people will write it as S-O-H, like that. Either way, it's opposite. So when you trace that angle, it's the side that you do not trace. So opposite and hypotenuse. Hypotenuse doesn't change. So we're dealing with right triangle trigonometry, which when we move into 9-7 next week, you're dealing with oblique triangles, meaning they're not right triangles anymore. All right, so opposite over hypotenuse. Cosine, so the cosine of A, in this case, we're dealing with the adjacent. So when you trace, the side that's not the hypotenuse is called our adjacent side. So this is adjacent to angle A. This is opposite of angle A. Okay, hypotenuse doesn't change. And that is really blurry. That helps. Okay, so in this case we have adjacent is B over C. Okay, and then tangent is opposite over adjacent, or A over B. So we have Sohcahtoa. You think of it as like that. That's kind of the phrase we remember, Sohcahtoa. Or how many remember this from geometry? Okay. Okay. Anyone not remember it from geometry? This is all chapter 11. So right now, those of you that use our calculators in this class, if you're dealing in radians, you'll note that a lot of times they're in a different mode because my geometry students are using them. And they're doing chapter 11 in geometry right now, which they're dealing with all degrees. Okay? So there are a lot of times you have to switch that around. So we have Sohcahtoa. That's what we remember. That's how we remember our ratios. Note that angle A, when we're dealing with angles, we're using all caps, uppercase letters now. When we're dealing with the side opposite angle A, that is side A. That's a lowercase. Uppercase is angles, lowercase are sides. Note that. Uppercase are angles, lowercase are sides. That's a big deal. Okay, that's how we start distinguishing between the two. The side opposite C, angle C, is side C. The side opposite angle B is side B. Okay, so I see some of you talking, see a few of you zoning out, so I'm going to assume you have that. We're going to move right on. All right, here we go. Moving on. Example number 1. I want you to, right now, work with your neighbors. You guys get a few minutes. Follow those directions. Here we go. You guys come on up, put the answers up. Yeah.
What? Cosine 4 over 5? For the answer?
Yeah.
No.
Yeah.
For what one? Oh, gosh dang it. I wrote the decimal values. It's just a... It is pretty exact. Write down the entire 4 over 5.
Why? We don't have one. Can I have your pencil?
We don't have one, Julia.
We don't have one at all?
No, we don't.
He said this group combined with this group. Right?
Yeah.
Who's doing one then?
We are. They are.
Yes, I'm 100%.
We are?
That's right.
Mr. McCoy, our table and Isabel had number 1, correct? Correct.
Why?
Yeah, he said us and Isabel.
But that would require listening.
Okay. So here we go. Check them. Use right triangle to find the exact values meaning the key of the trig ratios. Ratio means fraction. So here, cosine, we're dealing with cosine of A, we're dealing with the adjacent of A, right? If we're using Sohcahtoa, okay, that's adjacent over hypotenuse. So the adjacent of A, so if you trace it, it's the side you hit. That's not your hypotenuse, so this is adjacent over hypotenuse, so 4 over 5, okay? Cosine B, so this is adjacent to A. You'll note that the adjacent to B is actually what side in relation to A?
The opposite.
The opposite. This is the opposite of A, okay? The adjacent to A is what in relation to B? It's the opposite of B. Okay, hypotenuse is always the same. So when we're dealing with cosine of B, adjacent over hypotenuse, so 3 over 5. Tangent, opposite over adjacent. When we're dealing with A, the opposite of A is 3. Opposite of B is, or adjacent to A is 4. Okay, good. 3 over 4, and then we get 4 over 3 when we're dealing with angle B. Opposite over adjacent, so 4 over 3. All right, how many got those? Okay, that shouldn't be anything terribly new to you. 3, 4, 5 triangle using the trig ratios. Any questions on it? Okay, moving on. All right, let's try number 5. Okay, in triangle ABC, angle A is the right angle, and cosine of B is 1/2. Find cosine A, tan A, and sine A in fraction and decimal form. Work with your group. Okay, if you're struggling, start by drawing the right triangle. Okay?
Pythagoreans. Garbo.
Went a little long on this side, but it's okay. All right. So we're trying to find cos A and tan A and sine A, all in decimal and fraction form. Okay, each group has a number. I'm going to give you guys a number. We use the random number table to see who's coming up to fill out each one of these as well as our triangle. Okay, so to start out with, we're going to get the triangle filled out while you guys are still working. That's group. You guys are group 1, 2, 3, 4. You first 4 here are 5. You second 4 are 6. Okay, so first to get the triangle filled out, group 1. You guys come on up, fill out the triangle there.
Me?
Okay. Use a pencil, please. Just in case you make a mistake.
Oh, I'm flawless. Don't even worry.
Oh, really?
Yep. The angles are capital, right?
Yeah.
Say.
Don't forget A and B.
A.
I'm making my top.
What?
And W.
And
A.
then the little c can be 2.
A.
B.
B. B.
No need W's.
The little c is 2. And the little a is 1.
Okay.
Or you
Yeah,
can
but
do.
you don't know if the little b is 2, little a is 1.
Then, but then B would be 1√3.
Cosine of B.
Yeah, I know it works.
But we put it that way. Yeah, but we put it that way. That way.
Good? That work?
Yeah.
Yeah, that's it.
Alright.
But, wait, you don't know it's 30, 60, 90. Yeah. Just make it a little bit.
Okay, here we go. Let's double check this. Make sure we got it.
It's all wrong.
Everyone right now is looking at the triangle. Make sure that it matches yours. Okay.
Please be right.
Hey, so it says angle C is the right angle. Well done right there. Right? Okay. Cos of B. Here's angle B. Is the adjacent over the hypotenuse, so 1 over 2. Good job. Okay, so he's got it labeled correctly. And then root 3. How did you get root 3?
Because it's a right triangle, and then it's x, 2x, and x root 3.
Okay, so if we called this side length A is that, B is this, right? It's opposite B, and this is C. And so you use special right triangles, x, 2x, x root 3. Good job. Okay, you could have used the Pythagorean theorem, right?
Yeah.
So for those of you who didn't remember the special right triangle process, hopefully you use the Pythagorean theorem there. That's x root 3. Okay, nice work. So we don't need we could just put root 3, right? Okay, good. Okay, so group number 4, you get cosine, the decimal form of cos A. Group 6, you get the fraction form of cos A. Group 6, you get the decimal form of tan A. Group 2, you get the fraction form of tan A. Group 2, you get the sine form, or the decimal form of sine A. And group 1, you get the fraction form of sine A. Here we go. Let's get them done. Random number. Hey, it was random generated. Sorry. Okay, here we go.
Oh my goodness.
Hey, are we in agreement? We got root 3 over 2 for cos A. Good. Is root 3 over 2 0.87?
Yeah.
Who seconds that? A group that didn't do it. Anyone have a different answer? I haven't checked it. I'm assuming you guys have checked that. That's correct. Okay. Tan A. Is this a 3?
That's a. Is that's a.
Root 3 over 3?
That's a.
Okay.
How do you even 3 up there?
What?
Okay, so A.
Tan A is definitely 1 over.
Yeah, tan A would be opposite of A.
So 1 over root 3.
1 over root 3 maybe? Okay. Okay, so the ratio-wise, it's 1 over root 3, which then you multiply by root 3 over root 3, which gives us root 3 over...
3.
Hey, that's what he had.
Yeah.
All right, root 3 over 3. Hey, I'll put the star here. There you go. Root 3 over 3, is that 0.58?
Yep.
Yep, good job. Okay, and then sine A, opposite over hypotenuse, 1/2. Is that 0.5?
Yeah.
Put the 0 there. It's our hero. Okay? Here we go. Who's got it?
We do.
Questions? All right, moving on. Number 8. Take a look at it. Find the distance across the river if the angle of elevation. Angle of elevation, that's 11 dash.
5.
11-3.
Okay.
We're doing it tomorrow in geometry. Okay? There we go. Draw a picture. Okay, to begin with, while everyone's still working on this, pay attention, we have group number 5. You guys are coming up and drawing the picture. Okay? Here we go. Okay, let's check out the drawing that we have. Hey, we got 7.5, so find the distance across the river if the angle of elevation to the top of an 8-foot pole. So I'm assuming, is this your 8-foot pole? Okay. So is this A?
It's A.
Okay, so A equals 8. Okay. On the opposite side of the creek is 7.5 feet. The site height is 5 feet. What's that mean, the site height?
It's the site
Yeah.
of the height.
It's where the angle A starts. It's where your C is.
Good. It's from your horizontal. So let's pretend for a minute that this was someone standing right here. All right. Here, they can wave. Okay. They're saying hey. All right. And they're looking. Their sight height is 5 feet. That means this height from here to the ground they're standing on, if it's a right angle, is 5 feet. Right? This picture is not to scale. All right? This height then, if this total height of the pole is 8 feet, what's this height?
3 feet.
This is 3 feet. Now, we're really not to scale. Okay? And if this is 5 feet, okay, and this is 3 feet, we obviously have some drawing problems, okay, with the way we did it. But that's okay. Okay? So our total height is 5 feet. The triangle, that's 3 feet in height. And how far across the
5.
We're trying to figure this out, right?
So that's 5, 4.
This is letter B. So what do we use here?
Pythagorean Triple.
Could, if we knew this was 4.
Yeah.
Yeah?
Tangent of A equals 3 over B
Okay, so how did you know to use tangent?
because it's opposite over adjacent.
Okay, so they give you the opposite side, right? If we're looking at this triangle and just focusing in on angle A in relation to angle A, because that's the angle they gave you, you have the opposite, and then you're trying to find the adjacent. We don't care about the hypotenuse. So opposite and adjacent is tangent. So the tangent of our angle is equal to the opposite side over the adjacent side. 3 over B. Okay? So that means, hey, remember this is kind of, that's compacted together. Okay? We can't separate those two things. So in order to solve this, we cross multiply. That gives me B tan 7.5 equals 3. How do I get B by itself? Divide by tan 7.5. Okay, are we measuring in radians or degrees here?
Degrees?
Degrees. How do we know degrees?
Because it's degrees of the whole.
Yeah. They give you degrees right there. Okay? So, B is what?
1.1.
Make sure we're in degrees.
I got roughly 22.7.
Okay, not one.
I'm in radians.
Okay, 22 point. Let's go to the nearest 10.
8.
8 feet. Okay? So 22.8 feet.
Whoa.
All right.
Yeah, that might fix it.
Okay, how many had the picture correct?
Oh, yeah,
How many were struggling with how to draw the sight piece?
I did it.
Okay, so hopefully we know that now, right? So start by drawing your sight and then maybe draw a more accurate triangle. That's all right. I could have drew a really big. Yeah, that's okay. It's because 2 people drew it. I should have drawn a really big guy. I'm the one that made the mistake. I just don't have enough room.
But you're not one to blame people, so.
I'm not. Well, I'm blaming me.
But you're not one to blame people, so.
You're right. So it doesn't matter.
Everybody's innocent.
Okay, here we go. Example 4, number 10. In triangle DEF, angle D is a right angle. Find the measure of angle F to the nearest tenth of a degree in each triangle. Okay, draw your picture, number 10. We're going to only do number 10. We're not going to do number 11 together and run out of time if we do. So number 10. Group number 3, you got to quickly come up. Draw or label your triangle.
What'd you get?
That's group number 3, yeah? That's you guys, yeah. I think, isn't it? No, 1, 2, 3, 4. Yeah, you guys are 3. Okay, the rest of the groups, you should be finding angle F to the nearest 10th.
Tangent of 90.
Andrew, can you come help me?
So I know that one's D.
Yes, that's angle D.
Does it tell you which one F is supposed to be, or does it matter?
It doesn't matter because we don't want to draw this to scale. Leave it. Leave it. Just leave it.
Don't care.
Okay.
So then,
Now we know that this is F, this is E, and this is D, right?
Yeah.
Since we know F and E, we're going to use tangent.
I don't think we're
Because
solving
it's
it. I think we're
opposite
just drawing.
over-
I think we're just drawing.
Oh, drawing?
Yeah.
This one's E because it's the bigger angle. Like you just got the bigger side. No,
She's
you're drawing
right.
it wrong,
She's right.
Andrew.
Leave it.
She's very right.
I
and
am
you're
very
wrong.
right.
Yes, but
Yes.
oh, my eraser came off.
Whatever.
I got it. I got this.
This is also what I experienced.
Very,
That's very.
Andrew,
Go
that is
sit
very,
outside and think about what you just
yeah,
said.
That's not a good thing to say.
Especially to your math group of all women.
seem to have it right. Okay. Come on, Andrew. We got to respect everyone in our group. Whose pencil? Oh. All right. Hey, right here. We got our triangle. Angle D, angle E, angle... that one's E. Is this one F?
Yeah. Okay.
Oh, yes. You got it. Hey, opposite F, we're going to make this a lowercase f. All right. F equals 8. E, lowercase e is 15. Okay. And we're trying to find angle F to the nearest tenth of a degree. How do we do it? Group 2, what did you get? How do you do it? Yeah. Good. So we're trying to find F. So why are you using tangent? Good. If we trace angle F, we're dealing with the opposite side over the adjacent side. Okay, opposite over adjacent. So in that case, that's tangent. The tangent of F is equal to opposite, which is 8, over adjacent, which is 15. So we're trying to find angles. When you're trying to find sides, you're using sine, cosine, and tangent. All of those help you find sine, or sides. If you're finding angles, remember, you use an inverse sine, inverse cos. Brooks, are you okay?
Yeah.
An invert tan.
Comprehending.
Okay? All right, so in this case, we want to find the inverse tangent. We're going to have to move tangent over. We need to get F by itself. When we move tangent over, it becomes the inverse tangent of 8/15. That tells us F is equal to?
28.1.
28.1. Inverse tangent is located right above tangent, right? You got to use the second key. 28.1 to the nearest 10. Okay, how many got it? All right, I told you we weren't going to, well, before we move on, are there questions on that? No. I told you we weren't going to do number 11, but we're not going to spend a lot of time on it. I'm just going to change this for number 11. I'm going to call number 11 F is 1, and we now have D is 2. What are we using to find F? Inverse sine. Now, if we know sine of F is equal to 1 over 2, opposite over hypotenuse, where is sine F equal to 1/2? Where is sine equal to 1/2? Think of your unit circle.
30 degrees.
Good. F is going to equal 30 degrees. If you know your unit circle, that's an easy one. Think about those special relationships. Root 2 over 2, root 3 over 2. You could do this. You could go ahead and say F is equal to the inverse sine of 1/2, but it's going to give you 30 degrees. Okay? Everyone rate themselves 1 to 5. Covered a lot of stuff today. Okay? So we've covered the first 3 to 4 lessons of geometry that you did last year on Trig. Okay? Here's the last piece. It's the very last problem. This is the mixed side. Number 1. To measure, the two measures of a right triangle, ABC, are given. Find the remaining measures. This statement right here, a lot of time is also stated as complete the triangle. Complete the triangle means find all the other measures. That means all angles and all sides. Express your answers to the nearest 10. So, if they don't tell you what your right angle is, we're going to assume angle C is our right angle. So, there's my triangle. Here's angle C. Does it matter which one's A or B?
No.
Doesn't matter. Okay? If you want to go to scale, more to scale, you would probably call this one B.
What?
No, sorry, you call that one A. Okay, because opposite that is side A, which is 10. And here's B, and side B is 24. Okay, we need to know this angle this angle, and this side. Talk to your neighbor. How can you find one of the sides? How can we find the other side, side AB? How can we find side AB or side C? Go ahead. Stephanie, what do you got?
10 squared plus 24 squared equals c squared.
Good. You can do a squared plus b squared equals c squared. So in this case, 10 squared plus 24 squared equals c squared. I hear some of you saying Pythagorean triple.
Yes, sir.
Okay. What triple is it?
5, 12, 13.
Good. It's a 5, 12, 13. This is 5 doubled. This is 12 doubled. This is 13 doubled. So this is going to be 26. But if we finish this off, it'd be 100 plus 576 equals. Good. Okay. So we got the sides now. Now we need the angles. How are we going to find an angle? Good. So Julia's saying inverse. So which one do we want to use? Good. Now here's you guys. I said quit playing thumbsies there. Okay. Said which one do we want to use? Now in this case it doesn't matter. They're all exact. But if we would have calculated C and we would have had to round it, then you don't want to use that to calculate something else. Okay, because it's a round number. But in this case, if we want to find A, and maybe we use sine, opposite over hypotenuse, okay, we know the sine of A is equal to the opposite over the hypotenuse, or 10 over 26. Okay, do the inverse sine of A. We could reduce if you want. That's 5/13. It's not going to help us much to reduce it. But what do we get there? 20. Good, 22.62. We want to go to the nearest tenth, so 22.6. Tell your neighbor the quick way to find B.
Well, it's like plus that.
Okay, volunteer, what's the quick way? Brittany?
Subtract the first angle you found, or subtract 90 minus the first angle, or measure of angle A.
Good. These two angles have to add up to 90 because that one's 90 and all of them add up to 180. So that plus that is 90. So if we take 22.6 from 90, we'll know this. Okay? So 90 minus 22.6 tells us angle B. What is B?
67.4.
There we go.
Eat my brain.
That should be the measure of angle B.
Yeah.
All right. Very good. We have now completed the triangle. All right. Questions?